friends. How are you doing today? Awesome. It is nice to see you and welcome to the second week of the second semester. This week we're only doing one section, but we're only doing one because it's a doozy. It's going to take two videos. In the first video, we will be doing the first and third learning target. And then the second learning target I will save for the next video because it is your first lesson on what's called analytic trigonometry. We are going to use some what are called basic trigonometric identities to write some trigonometric proofs. I know you want to cry because I mentioned the word proofs. Don't cry. These are actually not as bad as the ones in geometry. Oh, look at that. I'm wearing a hoodie. I could look like one of my ninth grade students. Last year, ninth grade, I had two students who sat in the front and they always looked like this. How would you like to teach a class of students that looks like this? It's like, are you awake? Are you listening to music? What is happening there? Anyways, I won't do that to you. All right, so let's do these first and third learning targets in this video. Evaluate trigonometric functions of acute angles. Okay, example. If you know that the cosine of theta is 5/13, can you find the values of the other 5 trigonometric functions? Now, in the last week, I punted on that. I said, I don't want to talk about the other 3 trigonometric functions. This week, we're going to define the other 3 trigonometric functions as well. There are 6 trigonometric functions, and here they are. Let me give you an example, though. To draw the picture, you should always draw the picture. Don't try to solve a geometry question without a picture. All right, so here is a right triangle, and I will say this is the angle theta. So here's your hint before you start. What does it mean that the cosine of an angle is 5/13? Well, it means that the ratio of the adjacent side to the hypotenuse is 5/13. So that's what that means. Once you know that to be true, finding the other 6 is not hard because if you have a right triangle, you can find out how much that is. All you have to do is use the Pythagorean theorem. So let's do that. Let's do a squared plus b squared equals c squared. And if a is 5 and b is what you're trying to find out and c is 13, you solve, you get that b equals 12. So this would have to be 12. It's actually a 5, 12, 13 triangle. It's a very common triangle in geometry. It's a, what's it called? A Pythagorean triplet. Okay, so at this point, you know this. You know that if the cosine is 5/13, that will therefore imply, based upon the Pythagorean theorem, that the sine must be 12/13. You see that? Because the sine is the opposite over hypotenuse. And it will then imply that the tangent, well, what's the tangent? It's opposite over adjacent, so that is going to be 12/5. The key was that we had to find the missing side first. So when this question comes up in your assignment, find the missing side using the Pythagorean theorem, and then just write down the rest. All right, now there are 6 trigonometric ratios. So what about the other 3? You may have learned these in the past. I don't know. Anyways, there's a ratio called the secant, and the secant is basically the reciprocal of the cosine. So the secant is going to be 13/5. When the cosine is adjacent over hypotenuse, the secant is hypotenuse over adjacent. Always. That's what the secant is. It's the hypotenuse over the adjacent. The cosecant, abbreviated CSC, is the reciprocal of the sine. If the sine is the opposite over hypotenuse, then this will be the hypotenuse over the opposite, which is going to be, in this case, 13/12. That's your cosecant. And your cotangent is going to be the reciprocal of the tangent. So if the tangent was 12/5, the cotangent is going to be 5/12. Now the original tangent was opposite over adjacent, so this is going to be adjacent over opposite. That is a definition of these other trigonometric ratios. The secant goes with the cosine, the cosecant goes with the sine, and the cotangent goes with the tangent. Notice that each couple only has one co. There's a co there, a co there, and a co there. So the cosine goes with the secant. The cosine doesn't go with the cosecant because that would have 2 co's. You can only have 1 co in each pair. That's how you can remember that. It's a little trick. Okay, so you can have some questions like that on your assignment. Easy. Next one. This is learning target number 3, actually. And this one is using trig functions to solve real-world problems. In other words, it's just SOHCAHTOA. That's all it is. But you're going to have to do some problem solving. So let's do this one. Example. You are 2 things. Number one, you're in France, because that's the Eiffel Tower. And number two, you're a total nerd. Not only because you're in pre-calculus, but because you are measuring the angle of elevation between you and the Eiffel Tower as you walk along. That takes a nerd to do that. I would do that personally. All right, so let's keep on going. What's the question? When you're at point A, you notice that the angle of elevation is 37 degrees. This here is actually your angle of elevation, and that is 37 degrees. This one up here is technically called the angle of depression. But obviously, if the angle of depression is 37, the angle of elevation will be 37. Let me show you how that works out. You guys remember the two parallel lines cut by transversal? You know that this angle here and this angle here are called opposite interior angles, and they have to match. That's what we're looking at here. You keep walking along, and then you notice that once you're at point B, this angle of elevation is 72 degrees. In other words, this angle right here is 72 degrees. Now, knowing that the Eiffel Tower is 986 feet because you Googled it, the question is, how far are you now at this point B from the base of said lovely tower? How many of you guys have been to the Eiffel Tower already? 1, 2, 3, 4 of you. That's pretty cool. I've actually been there 7 times. Isn't that crazy? I know, I go to Paris too much. But anyways, let's keep on going. Let's answer the question. How much is X? Well, let's see. What could we do? What could we do? What could we do? I don't know. What could we do? Why don't you try solving it and then seeing if what you did is what I did? I don't know. Try something. Okay. Well, let's see what you come up with. Let's see. I know that if this angle here is 72, that means that this one is 72, which means that this one right here is going to be 18 degrees, right? That kind of seems to make sense. And since I'm trying to find out what this X is, I have an angle that's 18. And with respect to this 18-degree angle, I have an adjacent and I have an opposite, or I'm trying to find the opposite. So I could write this equation. I could say that the tangent of 18 degrees equals opposite over adjacent. And then I could use this as a proportion. So X times 1 is X. And 986 times the tangent of 18 is... well, I hope it's less than 986. Let's find out. Make sure that you are in degree mode before you do anything on your calculator, because if you're in radian mode, you're going to get the wrong answer. So I'm getting an answer of 320 feet. So I am 320 feet away from the base of the tower. All right. Now, there's some questions that are going to ask you to do a little bit more than this. They're going to ask you, for example, how far is A from B? So let's call this question B. We'll call this part A. And if I asked you question B, and I want to know how far is A from B, could you answer that? Why don't you try it? Okay, here is what I might have done. Well, let's see. I'm going to use red now. So I know that this big angle right here that I'm marking in red, I know this is 53. And I can't use right angle trigonometry inside this triangle right here that I'm shading in red, because this triangle that I'm shading in red is not a right triangle. So don't try to use SOHCAHTOA with something that's not a right triangle, okay? So, but what I can do is I can say, well, I could find the whole distance from A to C. That I could find. And so I could write this equation. I could say that the tangent of 53 degrees equals opposite, which is AC, that segment, over the height of the tower. So 53 is opposite over adjacent. All right, so once again, multiply there, and I could find out that AC is 986 times the tangent of 53. All right, that is 1,308 feet. So if the question was, how far is A from B, you could actually do that. All you would need to do at this point is say that the distance from BC is going to equal 1308 minus 320, so 988 feet. So that's how far that would be. 988 feet. So what's going to happen today is you're going to have questions where you have to do a few little calculations. It may not be one step, it may be 2 steps, maybe 3 steps. You might have to subtract and add a few things. So that's what one example that looks like. Okay. By the way, I have one little slight mistake here notationally. This, if I want the distance A to C, you put no hat on that. Shame on me. All righty, folks. That is the end of the first video. And come back for the second video because we're going to do some analytic trigonometry. Woohoo!